Welcome to this very interesting session. As you might have guessed, we speak English in this panel, so if you would need a translation to French, there's a headset, the entrance of the hangar. One of the panelists will speak in French. So for those who would like to get the most out of it, it's advisable to get a headset anyhow if you don't speak French, so they translate to English simultaneously. So, and what we will do in this panel is we will try and provide in 30 to 45 minutes a very interesting discussion about the tree fruit industry. We have some very interesting panelists over here, and I'm really delighted to have them on my panel and to be able to introduce them to you. We would like to focus on grower feedback on agricultural robots. So there's a lot of talk about agricultural robots, but what is really happening? Firstly, I would like to introduce my panelists on the left side of me, for you to the right. I will do a brief introduction and then I will let them introduce themselves, what they do. So right next to me we have Ignacio Iglesias. He's from Spain. He's from Spain, and he's from Agro Milora. He's an R&D director, and he has a lot of experience in fruit trees, a lot of experience on cost of production as well. He will explain more later. Next to him we have Marine Lourgan. She's from the CTIFL, an institution in France, and she's the head of the unit for mechanization, automation, imaging and sensors. Then we have, next to her, we have Efraim Albrecht Neto. He's from Brazil, and he's representing the Funda Citrus Growers Organization, also with a lot of experience, also looking for robotic and autonomous solutions for his members, his growers. And we have via Zoom, we have Savio Landonio, if I'm correct. Yeah? And you are from Avatec in Italy. And I understood you're a distributor of a certain model and type of robots. Thank you to the panelists. And for the people who don't know me, who haven't seen me before, I'm René Koerhuis. I'm an editor for Future Farming magazine, the global #1 on automation and robotics. And as I mentioned, delighted to have my panel right here. So I would like to start with Efraim. Can you briefly introduce yourself, Efraim? Yourself, your company, what you do, and what is your motivation to be on this panel?
Hello, everybody. Thanks so much, René, for this introduction. And I wanted to say thank you for all the organizers of the FIRA. For us, it's very important to be here and to talk about the subject, robotics in fruit harvest, right? I coordinate one project in Funda Citrus, who is a grower association in Brazil from the producers of orange in Brazil. As just for you have some idea, we have more than 500,000 hectares of citrus in Brazil. So it's a huge area, right? And in that case, we start this new project. The name is Harvest More, that we are looking for some solutions for new technologies that you can bring to Brazil to improve the harvest in Brazil, to help the farmers in Brazil to harvest the fruits, okay?
So, do you already have experience with robots?
Yes, I have a couple of experience, let's say like that. Last year, I have been here in FIRA, Toulouse, and we start a new beginning for the citrus area. We have some relationship with some companies, and then I can, during our panel, I can tell all the history about we start last year and in which phase we are right now.
Okay, we'll speak about that later then. Marine, can you also briefly introduce yourself, what you do, the company, and why you are here?
Bonjour à tous, donc Marine Loargan du Centre technique.
Good afternoon, Marine Langan. We are a research institute on fruit and is financed by professionals. We are going to work in collaboration with the professionals of the fruit and vegetable sectors to identify their needs, their priority projects, and robotics is part of the priorities to respond to issues experienced by the sectors, such as issues concerning labors or hard work. We are going to work with these producers, with the growers, to try to identify solutions, try them, see what their impacts, benefits, or disadvantages can be, and we're going to apply these solutions in the on the farms.
Thank you, Marine. And what is your motivation to be on this panel? Why would you like to be on this panel?
Donc ici, l'idée là pour le CTIF.
Well, here the idea is that we'll be able to detect the needs, the growers' needs, try to identify solutions, and transfer them to the farm holdings. The two priorities in France in this sector is automation of the harvest and the weeding. And there we have very few solutions marketed already in France. So there's a lot of work to do to develop new solutions or to assess prototypes and even to improve these solutions.
Ignacy, can you briefly introduce yourself? You have prepared a few slides, but we'll go into that later during the discussion.
Thank you very much for giving me the opportunity to be here. It's a pleasure to be with all of us. I have been working for almost 25 years at IRTA. It's a public institute of research in Catalonia, Spain. 8 years ago, I moved to Agromilora. It's a nursery company. It's a global company that is very innovative in terms of developing new models adapted to the mechanization and robotics. So we understand clearly that one of the main limitations of the future production is the labor. So we need to be thinking in the future how we can reduce, how we can be more efficient, and how we can be more sustainable. And of course, you will ask for me for sure. We have some of our clients that start to using these technologies. For example, for robotic harvest in apple, I will show you in a few minutes.
Thank you, Ignacy. Savio, can you hear us okay? The technology is all working, the techniques. Can you also briefly introduce yourself, your company, and what your relation is with robotics and automation?
Sorry. Thank you for the invitation on this table, and I'm one of the founder and CEO of Arvatec SRL. Arvatec is a company that born 23 years ago as a spin-off of Institute of Agricultural Engineering in Italy, and from 2002 we start with the commercialization and production of a precision farming system. In the last year, we start to approach the robotization in agriculture, and so we start to implement the first robotic tractor on a Fender tractor in 2016. And in the last years, so starting from 2021, we start the commercialization of some agricultural robots like FarmDroid FD20 and Peck Automotive, Slope Helper, and now Agile Helper also. And we are also in charge to start the commercialization of a new robot that we build ourselves that is called Mondino, that is specific for rice cultivation.
Okay, let's stick with you for a second then. So you were mentioning experience with autonomous tractors since 2016, if I understood well. That's quite a long time already.
Yes.
if you look, can you mention us what kind of brand and what kind of autonomous technology you used? What tractor was it? What technology was it?
In that year, we installed a robotic expert solution to attend the tractor. And it was our first experience with robotization on agriculture and on a tractor.
So that was the Dutch robotic solution then, from the Netherlands. Yeah. Okay. So if you look back, what went wrong and what went good? Can you name like 2 advantages and 2 disadvantages of that solution?
So if we talk about the expert solution, so the advantage, of course, was the automatization of the tractor operations. It was a good solution. The only small problems was that it was a wreck and play solution. So the tractor driver had to stay on the tractor and wreck all the operation, and then the system automatically replied operation. Of course, if the driver made some mistake, this mistake will be repeated in the next operations. By the way, one of the big disadvantages was to modify a standard tractor that was built to have an operator on board. And on this way, of course, we meet a lot of problems for road circulation, because it was, of course, homologated for road circulation and for insurance. And so another problem was about the tractor company that sometimes update the firmware of the ECU, and so we needed to update ourselves also the firmware of our ECU, because it was in connection between, and so on this way the project was good, but in the other side was not good.
Okay, thank you. So Ephraim, you were mentioning about, let's say, improving or more robotization in harvest of citrus fruits. If you look from a grower perspective, should an autonomous of a robot solution then harvest every fruit? Or would your growers also be okay with a robot harvesting 60% and human pickers still harvest 40%? Is there a certain trade-off point in percentage, or?
That's a good question. When we start that project with Fundecitrus, we talk with most of the growers in Brazil, right? We have big industries over there, Citrosuco, Cutrale, Luiz Dreyfus. I think it's the 3 biggest industries in the world. And they have that demand. They need to harvest the fruits. In our case, we are talking about the fruits to juice. It's different when you're thinking about the fresh market, right? So in our case, you don't need too much care about the fruits, but just for you have some idea, we have some companies in Brazil that they have more than 200 groups of harvests, people in harvest orange. Each of group has more than 40 people in the group, just for one company. So it's a lot of people over there. And then when you thinking about the orchards, right, the characteristics of the trees, we have some orchards with more than 20 years. So we have trees like 5, 6, 7, 8, very tall trees. And when you get these tall trees and you get one people to harvest the fruits in that kind of tree, you need to put some stairs. Sometimes they need to get like 6, 7 steps in each stairs. In that case, maybe if you develop a technology just to harvest the fruits in the top area of the trees, it will be a good solution for us. Maybe to start. Okay, in the end, everybody wants 100% because we know the field, you know, the temperature, you know, all this stuff. But maybe to start, I think you can divide this big challenge that you have in the front, right? This is my point of view. I have talked with as a few companies here about this perspective, not maybe to start to get 100%, but we need to start. I think this is the main point.
Okay, so my next question would be, you say maybe we should have a robotic solution to harvest the top parts of the fruit. I've also seen a solution in the USA where they actually change the type of orchards to match autonomy and robots. And I would like to have actually the opinion of all the panelists, starting with you again, Ephraim, just briefly. Should we adapt a robot to a standard orchard, or should we adapt an orchard to a robot? Ephraim, if you can answer first.
Okay. Well, we agree that the hard ones will go to Inas, but okay, I will try to answer that. I'm kidding. I think we need to looking for a way that will be good for all the sites. But as I said before, in Brazil, we have some orchards that more than 20 years. So it's very hard to put one robot over there to harvest all the fruits. Now, I have worked with Inácio and other team from Agro Melhora. They are developing new characteristics of the orchards. And then we are trying to move from these 3D orchards, big trees, to deep 2D orchards, right? Like a wall, and then you can put the robot over there to harvest the fruit. So for me, I think we need to think to change the orchard's characteristics.
So that looks a bit like robotization in greenhouses, for instance, where they tune the method of growing to the automation. Marine, can or would you like to say something about that as well? Should we change production systems for robots, or should we change the robots to production systems?
Un peu des deux.
A bit of both. Well, typically, we must understand that we are not going to be able to change the orchards overnight because the crops are there for 10, 15 years or more, and therefore growers are not going to be able to change their practices so easily and overnight. There's a lot of research being done on 2D cultivation. We'll be able to change the spacing between rows, flatten the hedges so that everything can be easily accessible by the machine. We can work on that as well as on varieties. We're starting to study the varieties which are less sensitive to mechanization and those that can be more easily adapted to new machines. We've been working for many years on these issues, and we have been able to demonstrate that we can increase the performance of the plant at economic and technical level, and it makes mechanization easier. How can we deploy this onto the farms? Because the crops that the growers have had for 10, 15 years, they don't want to pull them out straight away. Now we are studying now 3D orchards, and we are going towards 2D as well. This is developed more and more.
Yeah. Very valuable. Yes, Ignacy.
I think it will be better to show some slides. Do you think? Just to illustrate.
If we could start with an answer to the question. So should we change the type of orchard to robots, to machines, or should we change robots to orchards from your perspective?
It's very clear. We should change and adapt the trees to the machines and robots. Okay. We did this over the last 40 years. So I think there is no other options. You can imagine how difficult could be for the robots to pick the apples in open base. It would be impossible. If you transform this canopy, this architecture in a planar system, the accessibility is increased by 80%. So this is the question. And in the meantime, these orchards, we can go for mechanization with a high precision. And finally, with this orchard, the light distribution is better and the fruit quality is increased. So I think it's not any question. There is a lot of scientific reports that we need planar canopies for all these technologies. We cannot be thinking in precision agriculture without planar canopies. This is very clear. I have a couple of slides. Could be possible to show
We will
the
show
audience?
them. We will show them when the time's ready.
Okay.
Ignacy, just a second.
And finally, another question. I think the benefit of these canopies is we combine these canopies with the intensification. We can be more sustainable because we can get early yields and our payback will be reduced. So I think it's a mix of factors that for sure will be the future of fruit production. And of course, I am thinking on apples, on pears, on peaches, very sensitive fruits to bruising. So the machine that we develop should be very, very, very efficient because the bruising is not allowed. And the last question you ask about which average of yield we can pick from the robots or clients. We have experience with three clients in Chile, Argentina, and Australia. With the last robots that I can show you after if we have time, we can go with these planar canopies around 85% of the total production. So I think this is possible, but I am convinced that the future is the architecture of the trees adapted to the mechanization and robotics and also to the labor. Because the labor, if we need labor, is more efficient in a planar canopy, but compared with a three-dimensional canopy, is 40% more efficient. The labor of pruning, of whatever. So no, I think there is not plan B.
Good. It's always to have just one plan, except for when the one plan goes wrong. Thanks for the discussion. Different answers, so different opinions as well. If we go to Italy, what do you think? Should we adapt orchards to machines, or should we adapt machines to orchards? And how much of a fruit should be harvested by robots? We don't have sound right now, but I don't know if it's the technology or if it's at your end.
Sorry.
Yes.
I was telling that I agree with the other colleague that speak before me. I think that in the same way that we did in the past with the tractor mechanization, we have to adapt the cultivation to the mechanization. And on this case, we are now in the step to the robotization. And so I think the good way is to adapt the canopy to the robotization. Because we can improve the productivity, we can improve the results of the picking with the robots, but also the pruning and also all the other operation, also precision farming. For example, mapping the vigor of the trees can be more easy if the tree is 2D and not 3D. But the percentage of the picking with a robot, I think can be a good result to reach the 70–80% of the total production, and then can be also good to integrate these, for example, with the 20% of manual harvesting to complete the works done by the robot. Or if there are no advantage for the cost, okay, can be good to pick up only the 80% and leave the 20% of the trees. So it's not the best way, the best solution, but if the cost of the handwork is too much expensive, probably in some cases there is no sense.
Okay, thank you very much for all your opinions. It's interesting to see the diversity on the opinions and the ways to work. Another question on robotics. If we look to orchards and the different types of crops you basically represent, should a robot, where do you see the most benefits of a robot? Is it harvesting? Is it spraying? Should it be a combination? Should a robot do multiple tasks, or do you want a harvesting robot in particular, a weeding robot? I'd like to start with Ephraim again. What's your opinion on that?
I think you can have different points of view. If you talk with the producers, they want just one machine to do all the jobs, right? Like a platform, like equipment that it can maybe do the harvest, the spraying, the weeder, all the operations. But maybe when you look for the point of view of the companies here who are developing the solutions, it's not so simple. You get the best operation with the same equipment, right? So it's like a dilemma. But so in Brazil, we say the consumer always has the right. So I think the better options it will be if you have one machine, one solution that could be work in a different phases of the production.
Yeah, because I'm also not only thinking about the job or the task, but also on the return on investment. I mean,
of course,
it should probably replace a tractor like now, but if you have a harvesting robot, a pruning robot, a spraying robot, that will need quite an investment, and there also has to be an ROI on that one.
Of course, and in the Brazil, we have our harvest season from March to the end of the year, sometimes until February. So we spend a lot of months of the year harvesting the fruit. I'm talking about juice markets, right? In that case, maybe you can have one machine just to harvest and change the machine during all the months, during the different farms, the different orchards. But I think the most desirable thing is about to have one solution to do different jobs.
Marine, what's your opinion?
Ça va aussi dépendre du coût.
It depends also on the cost of the machine. It depends on the cost of the machine. To develop a solution that would be able to do everything, well, that would mean that the machine will cost a lot of money, and I'm not sure that there will be a return on investment rather than having several solutions, several specialized solutions. All the more because some tasks will be carried out at the same time in parallel. So we won't be able to have one machine doing everything because there will be several tasks to perform. And therefore, we'll have to see according to the needs on the plots. Now, concerning the advantages of the solutions, to remedy the shortage of labor with the use of chemicals, for example, or plant protection products, there will be different solutions for the spraying, and these solutions on apple orchards, for example, the trees will be treated regularly. And if in the future we have to use products that are not so efficient, we'll have to use the machines more and more. And if the tasks are multiple and have to be carried out at the same time, it will be a problem. So in some cases, it will be interesting to have specialized solutions. But obviously, ideally, the grower will want a machine that does everything. But there are intermediate solutions as well, like a robot that will carry implements. A robot on which you can install modules, automated or not, and then there will be a common module for all tasks, and then we change the implement according to the tasks to be performed. So there would be a common platform, and then we would add the right implements as needed.
Say, growers, farmers want to replace a tractor where they are on. They want to have a carrier vehicle, an implement carrier to do different tasks. Ignacy, what's your opinion?
Yes.
Where's the most benefit? And
I think
this multitask could be a good option, but I think we need to put the focus in one thing. In apple, pear, or peaches, the labor is 50% of the cost of production, and the harvest from this 50% is 80%. So which is the focus? The harvest, of course, but it's the most difficult. For example, in grapes or in olives, we have orchards, 1,000, 2,000, 300,000 hectares in California, for example, that is full mechanization of pruning and harvested with almonds and olives. But with other crops, as citrus, apples, pears, and peach, the most difficult is the harvest, but it's the more time consuming. So this will be the next step. And another important task is the winter pruning. You can imagine how difficult will be with a robot the winter pruning in an apple, for example. So this is the most complex. So I think we need to go step by step. But for me, the closer solution is the robotic harvest, because we have important experience demonstrating that is possible. But for the winter pruning will be another challenge. But for example, let's put another example. In peach, pear, and apple, the summer pruning is 100% mechanized. So let's go different species, different problems. But for me, the focus of the next decade will be first harvest, and the second will be the pruning, winter pruning. That is very complex.
So basically, if you have an autonomous tractor, you could do the summer pruning also autonomous.
Yeah, of course. In fact, we start doing in Brazil, in apple, we have some experience that the summer pruning, that is not a specific pruning. We pass the machine. We are cutting just in summer. We do the pruning, the harvesting, and the spraying with the same machine. It's a common platform, and we change the head of the machine, and we do this now mechanically 100%. If you go to apple, pear, or peach, or citrus, it's another history, because these high value products, so it's very more difficult to not bruising the fruit. So this is the complexity.
Okay. Thank you all for your insights. I would like to a last question from my side, because there's maybe a question here and there in the audience, and we have a few slides you would like to show as well. I mentioned I'm from Future Farming, and we try to distinguish the promises of solutions from the farmer-friendly solutions. So what does really work? And I'm curious from my panelists, because if you want to sell a robot, you promise a lot. So have you experience with you don't have to mention the name of the manufacturer, but do you have experience with over-promising in Italy? You've experience with the autonomous tractors, with the robots. Do the manufacturers often say it can do everything, but there's always a drawback on it? What is your experience? Do they overpromise?
I think yes. So of course we have to pay attention of overpromise to the customer, because we risk to damage the market. Normally our work is to talk with the customer, understand what are the needs of the customer, and choose the correct solution for that situation. For every customer can be different. About the company that build robots, for sure, all of them, they have big goals, big ideas, and the most important thing is that the way they are following is the good way. For sure, there is not at the moment a solution that is perfect, because especially on the robot market, all is new and all is under developing. And so for sure, we have not the perfect solution now, but we are working to have a better solution in the future. And the most important thing is to go step by step and start with the solution that is more ready for the market at the moment, and then improve this, and then eventually add other solution in the future. About the discussion you was telling before, for sure the multi operation robot can be the best solution for the question economics point of view. And on this way, we can start from the implement that it is more easy and more ready now at the moment. Start with this, and then go away, go ahead with other implement. And of course, I agree with the other people that the harvesting is one of the most interesting solution, and it is of course one of the most difficult operation to do. But also in this operation, all we are working on that in this way, and for sure in the next future we will be ready to work on a good way also for harvesting.
Okay, thank you for your insights. Ephraim, you've been to the last FIRA here. Maybe you've been to the USA one as well. How do you think about that? Do they overpromise?
I think overpromise it's maybe not the right word, right? Because if you're thinking about the robots, okay, to be fair, I don't think you have one company that have more than 500 of robots in the field, as I know, right? So when we're thinking about our growers in Brazil, just one of our industries, they have more than 1,000 tractors in the field. So if you change the view to the companies who are developing this new technology, maybe they consider in the beginning, I can get in the end with all my process. But maybe during this this path, they are surprised by another things that they don't imagine in the beginning. So I think this is my point of view, right? It's very hard to have real operations in the real field. When sometimes we saw some equipments, I say some parts of hardware together operating in situations that you can control all the things, but in the real life is different. And then think this is the point, right? It's a hard way for you to have the equipment, the machine in the field. And for us in Brazil, you can imagine, we can maybe buy different kinds of robots, but we need to have the parts, we need to train the people over there. So I think maybe in this way we can talk about these promises.
Okay, good. Marine, do you have something to add to that, to the promise made?
Oui, une des problématiques qu'on peut avoir, enfin en tout cas qu'on a eu.
One of the problems we've had with some equipment manufacturers is that indeed 5 or 6 years ago we had tested the autonomous tractor, and we had realized that they had not anticipated after sales service, maintenance, the support for the companies about details. We are in France, and everything was in English. But when you have a grower, a technician that only speaks French, already that makes it difficult. The dialogue is difficult. And in this sector, we have very few companies. And when we deploy a solution in another country, several issues arise. The technical itinerary, the technical aspects, they change, and some manufacturers had not anticipated those differences, which created some bugs. So all these issues, I think, are being overcome by the equipment manufacturers and the dealers as well, because all these stakeholders are starting to have this experience now. And we can see less and less producers or growers complaining. There's still some bugs now and again, but just like you have bugs with tractors, and the performance is better and better. We have gone a long way, progressed, but we still got to work on some things. Above all, when we have equipment manufacturers dealing with new species, some of them present solutions that are still prototypes, and they want to go too fast with the producers without having tested and finalized their solutions. So this phase is extremely important.
Thank you, Marine. I want to take time if there's one burning question in the audience to the panelists. I see Ben.
Thank you for the panel. It's a great discussion. You know, something I think about when you talk about if we have to change the plants, change the way that if you grow, you know, citrus, for example, on a 2D for the robots, that's not going to happen overnight. But companies that are developing these robots have to develop that technology now. And that technology for a 2D system versus to fit now in your current 500,000 hectares of citrus, right? So companies try to decide, you know, what does my hardware look like? And if I do it for a specific thing, it might not carry over to the other thing, right? So the question is, it's a chicken and an egg discussion of, yes, we need that, but how do we, you know, and conversely, if all of a sudden everything goes to 2D and I've developed a solution for the trees are today, then I have to completely redesign that entire product. So, you know, the question is, how do we, you know, how fast do you think some of those changes are coming? And are they coming at a speed where you can communicate that to the robot designers and manufacturers and they're not pigeonholed into a single design for one specific part of the industry?
Thank you, Ben. We have talked in these days, right, about a lot of solutions, a lot of opportunities, and I agree. And for me, I think other thing is about the solution. Maybe if you have the solution ready to operate in the field, the growers has had more, they want more to change the orchards, right? I think could be a good thing. Because now they are just discussing, oh, but if I change my orchard and the solution doesn't work. So I think we are in this way to improve the solutions, the robotic solutions. And in the other hand, the growers will see these steps that we're getting and then thinking about, oh, maybe now it's time for me to change my orchards. Maybe I will change just in 4 years, but now I already have the solutions I can change in the next year.
Okay, we have to round up. And before we have the slides of Ignacy, I would like to thank all the panelists. I hope you enjoyed the discussion. Maybe you've heard an interesting point from one of the panelists. My sincere thank you to everyone here also via Zoom. I hope you enjoyed as well. Enjoy FIRA and stay seated. Keep your headphones with you because after a few slides from Ignacy, with some practical experience, there's probably an even more interesting panel discussion. So do sit around and stay here if you can.
Thank you very much. I will show you only 4 slides. I think it's very important to have the image. You can compare these 2 images. This is the most important change of the history of fruit production. See the traditional orchard, see the new orchard. It's not only adaptation to the robotics, to mechanization. This orchard is much more efficient in all, in labor, in water, in nitrogen, in pesticides. This is the efficiency, not only for robotics, for all the things is more efficient. Let's go to the harvest. Imagine these trees in Italy, 15 meters tall, this tree, in the South Tyrol. Then we move to Oregon. This ladder has 14 steps. Let's go to Spain. This is Spain here. This is Oregon. This is Italy, 20 years ago. And the next step, robotics. But if you go to here, see how we prepare the orchard to the next step. It's what we are doing in the most of the European countries. Let's go to one example. This is the, table company. This developed the first flying robots. For me, it's a bit difficult to combine the stability of the drone with the efficiency of harvest, in my opinion. But has been the first idea to the robotic harvest. This is in process. Some of our clients, right? Sorry, we lost what happened? Now, okay, is running. So you can imagine how complex is the robotics. To see the apples, you can imagine what will happen in a three-dimensional tree. It will be impossible to be efficient. And the last one, let's go. This is still a prototype in your left, and in the right is the real robot picking apples this autumn in Duncan Brothers in Washington. This is the most efficient now we have for harvesting apples. It's around 30 tons in 10 hours. So each 3 seconds, one apple. This is the most advanced prototype, and you can see how will be difficult if this will be not a planar system. Will be impossible to be efficient. So I repeat again, we need planar canopies to be efficient, not only in robotics and mechanization, but also in input efficiency. Okay? So thank you very much.
Thank you. I hope you enjoyed the last slides. Thank you for being here, and stay around for the next panel discussion, please.